Would you just do like it's a sort of table
Mm-hmm.
where you would just put like humanities and then like science or like yeah. And then wait no, you have to do like one on one side and one on the other because there's 11 students who study both. So you have to do one horizontally and one vertically. Isn't that how you draw a two-way table?
Ah, okay.
Yeah, like that. So then, there's 11 who study both, so you can just put that there. And then it says 25 study only humanities subjects. So then you would put that as well underneath the 11.
So let's say we put a second H there.
Yeah,
So that is what was that one? Sorry.
25. And
Okay.
then there's 37, which is only science.
Only science.
Then because there's 75, you can just subtract to find the last value, which is 2.
Two. Okay. I just want to see how they wrote it. So they wrote it as H dash and S dash.
Mhm.
Okay. Oh, and then they wanted even the
Totals.
totals. I think okay. Yeah, it'll help for the next part.
So that one's um 48
Yeah. And
and 27. And then that gives you 75 in total. And then 39 and 36.
that's it.
And,
Okay. Part B.
wouldn't part be like the first one? Wouldn't it just be 2?
Two. Okay.
It's 75.
Oh, probability. Yes. So 2/75.
And then the second one, I got 11/36.
Okay. Third one.
Um, 25/27.
25/27. And how did you get that?
I did PH intersection with S dash over P S dash.
So, oh, so S dash. Yes. So let's see this one, and we wanted H, and so it is H out of that. So it's out of. I thought it would be out of 39 for this one, the S dash.
Um,
Maybe I'm looking at it the wrong way. 25/27. Yes, 25/7. Fine. I just labeled them wrong. Any questions there?
no.
Okay. Let's see. Okay, how do we do this?
So for sample space, you have to do, because it's two four-sided dice, then like you do 1, 2, 3, 4, and then you do it like vertically as well.
Mm-hmm.
And then you have to add them together. So then you would do like 1 plus 1 is 2, and then 1 plus 2 is 3, and like just go on. So you have to write all the possibilities out. So it would be like, so underneath the 1 has to be 2, 3, 4, 5, and then, yeah.
Yeah, and so on. Okay, part B.
Mm. I got 1/4, but I'm not sure if it's right.
How do you get a quarter?
I did 2/16 divided by 8/16
Um,
because it says given that, so you need the conditional probability formula. So you
yeah.
have to do the intersection between sum equals 5 and one dice landing on a 3, the whole thing divided by the probability of landing on 3.
So I'm going to use part A, and I think that's why they gave it. They
Yeah.
made us do it. So either we can get this 3,
Mm-hmm.
or we can get this 3.
Yeah.
How many 5s? Or we can get both, I suppose. How many 5s are there?
2.
And out of what?
16.
It would be 16, but it is given.
Oh, so would it be 8?
I believe so, which is the same as?
Oh, okay. 1/4.
I believe so. And okay, hold on 1 second. Oh yeah, how about C?
I don't know about C.
State 1 modeling assumption.
Is it like the dice are unbiased or something?
Unbiased dice. I think what they're driving at is that the dice are independent.
Oh, yeah.
But I like your one. Technically, that's true, I believe. Dice are independent. That was 2/7. We have to go back. All outcomes are likely, i.e. both dice are fair. Yeah, that's what they're looking for. So this was the sample space diagram. Let's just say 5, 6, 7. Oh, so they just have it the other way around.
Right.
That lands on a 3. That lands on a 3. Oh, that's why. See this one here?
Mm-hmm.
That is included in both of them. So if you count 1, 2, 3, 4, you don't count it twice.
Oh, that's why it's out of 7. Okay.
Yeah, that's it. I always forget that one. Okay. Any questions there?
Not really.
Okay. These are the exam questions. Let me just see something for a sec. Oh, do I have maybe 7, 8, 9? That's a 6. So this is 2B. Not there. That is question 8 of 2. Yes, this is okay. Just checking that I have all of them. Excuse me. Okay. 2A table to show this information. Probably not that. How could... No, I think you're good for that. How could you do part C?
Oh, you do the probability of L given H. Wait, no, you do, yeah, is equal to the probability of L. Or
Yes.
you could do this another one as well. There's the intersection of L and H is equal to P, the probability of L times the probability of H.
Yeah.
There's two ways.
So I think you're good. So they use the multiplying one.
Yeah.
Okay, let's see this one. These male, not that and not that. I think you're good for these. I think you're fine. You did it. Machine is chosen at random. Draw a two-way table. I think you're good. This is stick, given that they're female. These are very similar. Yeah, okay. Conditional probability. How do you feel about that?
Isn't that just like the given one,
Yeah.
the formula?
Yeah.
Yeah.
So this one is the tables one, and so the tables aren't too bad. Okay, let's try this one.
So the Venn diagram, so you know the intersection, so then you can just put 0.15 in the middle.
Mm-hmm.
And then A would be 0.4. And then B would be 0.25. So then to find A given B, you have to do probability of the intersection over B. So you would do 0.15 over 0.4, which is 0.375.
Okay. B.
Probability. Would that be 0.4 over... It would be over 0.8.
Yep.
Which is 0.5, I think.
Mm-hmm.
Yeah. So the intersection between not A and not B would be like what's in the box outside,
Yeah.
which is 0.2.
Yes, and that's just the one thing that was missing from the
Yeah.
Venn diagram. Okay.
And then over not B, which would be 0.6. So 0.2 divided by 0.6, which is 1/3. Yeah.
So you say, what was it? Over 0. What was it over 0.6? 0.2?
2 and 0.6, which is 1/3, 0.33.
How did you get the probability of not B?
I just did 1 minus 0.4, which is the probability of B.
How do you get the probability of not A?
You do 1 minus 0.55,
What do you get?
0.45.
Yes. And so, how will that change things? Will that change anything?
Yeah, it'll be different.
Go on, do it.
It gives me 0.75. If you do 0.45 divided by 0.6.
Okay. 0.75 was it?
Yeah.
So I think it's 0.75. That looks good to me.
Why would it be 0.6?
Why did I go wrong? You were right. Why are you always right and why am I always wrong? The probability of not A is 0.45.
It's because it's given, so you have to do the intersection between on the top. Like,
I forgot the given. That's why. Why do you listen to me? I don't know anything. There we go. Correct. A million times. Okay. And I thought you might forget the 0.2, but you didn't in the end. Any questions there?
no, I understand it.
Okay. So not B.
Some of the harder questions, like, I get confused.
Okay, so not B was these two, and then not A was this one. So that doesn't. Okay, let's see. So these exam questions are the ones that I just need to check. That's okay. So we'll start with the one I have. I'll see if it's worth doing. So they give us this Venn diagram.
Oh, I think I did this because you gave it to me for like last week.
I'm a smart man. So what I didn't give to you was this one.
Yeah, I didn't do that.
And yeah, brilliant. So how did you find those questions? There's how many questions?
Found it okay. There were like one or two that I got wrong, but then I understood them afterwards.
Okay, that's grand. So I like that. So we can be more efficient with our lessons, because with A level, it's so difficult to get everything covered, and that's why teachers kind of just race through it. Okay, let's see if this is worth doing. Oh wow, yeah, maybe we should do this.
Oh wow, it's confusing.
So this is this large data set stuff.
So what's a Venn diagram? So you need 3 circles, R, S, and T.
Okay, but what way do those Venn diagrams go?
I don't think any of them are like mutually exclusive. So
See, I'm just not seeing R and S and T.
oh yeah, there's no middle thing. So then it should be like in a straight line. All
So
three of them.
this is my guess to begin with.
Yeah, because there's no middle. All of them. And then
Okay.
just fill it in because only R is 3.
Yeah, they've actually made that part simple.
Oh, but T should be in the middle, not S.
Yes. They're snaking me. So
You can just fill in the information.
R and T.
Not S is 4 in the intersection.
Yeah, but which intersection?
R and T.
Yeah, you're right. R and T, but then S is 4. Only S is 12. S and T, but not R.
Is 4.
Only T. Not. What about this last one?
It's in the box on the outside.
Yeah. Okay, part A.
Okay, so
Temperatures.
I got 3/20, but I'm not sure. It's a bit confusing.
Let's go with 3/20. And how do we do C?
You just, so you know the intersection is 4/30.
Mm-hmm.
So then you just do 5/30 times 12/30, which is not 4/30, so they're not independent.
So is it 16/30 for S?
Oh, it would be 16. Oh, I did 12.
Okay.
And then that means T would be 13. Yeah, but that's still not going to give you 4/30, so.
So that's not 4/30, therefore not independent. This is question 7. Remind me, which exam board are you doing?
OCRMEI.
Okay. Oh, no. Where's this thing gone? Okay, so I don't need to be too worried about the wording about this. Alright. Grant, any questions there?
I'm just not sure if I got part 3 right because I got a bit confused.
This is 2.3. There we go. Question 7. That is not the question 7. That's 2.4. 3/20. Yep, that's correct. Boom. This one you did. This one you probably also did. So let me take a look at this other one. That's very similar. I like the look of question 9 though.
Well, I think I did that one. Or something like really similar.
Yeah, it's very, very similar. So we're okay for that.
I did this one as well.
Yeah, and so I like the look of this one. Question 9, allegedly hardest one. Okay, how do we do this one?
I think I might have done it.
You probably did one similar. What is it? Is it easy? You think you'll be okay with it?
I mean, the first question I did like of that type, I didn't really know how to do it.
Right.
But like once I figured out how to do it, then it was pretty easy.
Excellent. Okay, do it then. If it's easy.
So So because you know that P of A given B is equal to P of A, then you know that X over probability X plus Y is equal to 0.08. And then you also know that 0.08 plus X plus Y is equal to 0.88. So then you know that X plus Y is equal to 0.8.
Right.
So then you can just substitute like one for the other. So then you can just do X is equal to 0.8 minus y.
And what you can also do is simultaneous equations if you like.
Yeah, I just find this way easier.
All right, go on.
So then you can do x over, wait, no, that's, oh wait, you can do 0.8 minus y over 0.8. 0.0. I got y is equal to 0.736, and that means x is equal to 0.064.
You better be right about this. This is question 9. I have to make sure I don't make the same mistake again. You're not right. Oh,
Wait,
I think it was the first bit where you went wrong. Let's see. So this part here is just fundamentally when you add everything up, you get 1.
yeah.
And so we will do 1 minus 0.08 minus 0.12. So that's 0.8.
8.
So x plus y is equal to 0.8. Did you get that?
Yeah, I wrote that.
Okay, so that part's the equation 1. Equation 2 is this independent thing. So the probability, that tells me that they are independent.
Oh, I did it a different way, but
Yes, so doesn't that mean that they're independent if A
yeah,
given B is equal to?
because you can just like use the conditional probability formula. That's what I did.
So what formula did you use?
I did P of A intersection B over PB is equal to PA.
It's equal to P of A. And what values did you sub in here?
So then A intersection B is X.
Mm-hmm.
And then probability of B is X plus Y. And P of A is, oh, that's why I went wrong. P of A is 0.08 plus X, and I didn't put the plus X on the end.
Okay. So go on, try that again.
Mm-hmm. I got y is equal to 0.48 and x is equal to 0.32.
Looks good. And there we go. 0.32, 0.48. So Grant, so that was just a little thing. Yes. Everyone forgets that A is both regions, B is both regions. Any questions there?
No, I think this question, like once you figure out how to do it, then it's okay.
Yeah. And then these ones you've done. So conditional probabilities, Venn diagrams.
Yeah, I think I understand it.
I think so too. It's just a little thing. Probability formula, you're pretty good. You're pretty good.
I think I did these as well.
Let me just check. So, let me just see. So this is question 8. This is question 9, so it should be easier. Given 3 things, A, B, and intersection, find some stuff. You're given A, B, and intersection, find some stuff. My guess is you'll be good. Let me just go back a sec. So question 9, that's more challenging with 3. A, B, C, and an intersection. And how did you find these ones?
All right.
Okay. And that one, if you're able to do that one, then my guess is you're fine. How did you find tree diagrams?
I didn't actually do the tree diagram questions because I did this in GCSE as well, so I know how to do tree diagrams and I'm pretty confident with them.
You cheek this man. Okay. Because there's a
But I don't mind like practicing.
no, it's all right. It's just because there's a little more to it. I'll just show you. This is the bit that's a bit more to it. So if you think about it, if this is the probability of A, this is the probability of B given A because you've already passed A.
Yeah.
And so this is the only stuff to remember. And so it kind of takes a bit of common sense. Like that's A dash, that type of thing. And so the probability of both would be probability of A times probability of B given A. So you'd be using these values for like with the formula.
Okay.
If you're
So
happy, I'm happy. Let me just see what these look like. Yeah. Sure. Wow. So that's tree diagrams. Then we've got mixed. Okay, we can do. Let's try a real tricky one for tree diagrams. Perhaps I don't really like those ones. I think this is the one to do. Yeah. Okay, let's try this one.
how do you do a tree diagram for that one?
Box containers, green and blue. So this one's going to be green. This one's going to be blue. Or do I say not green? Who knows? Green and blue. A box B, green and blue. So this was going to be box A.
Mm-hmm.
And then you would kind of go from there.
Okay.
And then this would be box B.
Oh, that makes okay. I think I know how to do it now.
Okay.
I don't really know how to draw it in a tree diagram because it's like taking two counters off and out and putting it in another box. Like,
Oh, okay. Sure. So we've got a tree diagram. I'll fill in the stuff. How do we do B? No, you don't know how to draw the Venn diagram for this. What would be the probabilities for box B?
like just normally or after a counter is placed in it?
Yeah, after.
So if the count is green, then it would be 3 out of 6 for green, and then 3/6 for blue.
But let's see this one. Yeah. So it's green, it's put there. So that's 3/6. Maybe I do. Okay. Part B.
That's also 3/6. And if the count is blue, then it would be 2/6 for the green one, and then 4/6 for the blue one.
6. And then they take a third one, do they?
Second.
But it says a third counter.
But I only did the probabilities for taking out one and putting it in there.
But so that's correct so far. In place of box B, a third counter is then drawn at random from counters in box B. But we don't need to actually do anything from there.
Yeah, but those probabilities are only for putting, because you know how it says a counter is drawn at random from box A and placed in box B, and then a second counter is drawn. Those probabilities are not for the second counter. I only did it for one because I wasn't sure how to do it.
Yeah. Okay, so how do we do part B? Probability of C. 2 counters drawn from box A of the same color.
Wouldn't that just be 4/7 times 3/6 plus 3/7 times 2/6?
Yep. How about part C?
Show that PD. The counter drawn from box D is blue. I'm not sure how to do that.
The event D occurs when the counter drawn from box B is blue. Probability of getting a blue from B.
3/6.
So I believe if you get a blue, that would have to be the probability of a blue given green. And what would be this blue down here?
That would not be in blue given green. So it would just be 3/6 then. Wait, no. It wouldn't be 3/6. It would be 4/7 times 3/6 over 4/7.
So what is, without any numbers though, so this one down here, how could you get here to this blue?
Take out one blue from A and put it into box B.
Yes. And so that would be the probability of blue, given that you already took a blue.
Yeah.
And what would you do with these two?
You would add them.
Yes. And so the probability of blue given green. Yeah, it's just 3/6, isn't it? No, it's not. It's a whole bunch of stuff.
It's 4/7 times 3/6 over 4/7.
3/6.
That would just give you 3/6.
I don't like it. I don't like this one bit. Let me see this one.
Oh, but it's not 3/6 because a second counter is drawn, so it should be 4/6 and not 3/6.
Show that the probability of D D is when the counter is drawn from box B is blue. So is it just 4 over 7 times 3 over 6 plus 3 over 7 times 4 over 6? Yeah. So that's just simple stuff. That's 12 over 42.
That's 4 over 7. It doesn't give you
Nah, where am I going wrong?
27 over 40.
So that looks like 7 times 7 on the bottom to me.
And 3 times 9. Or 3 times 3 times 3.
Maybe. Let's see. So this is question 10. Why did I have to pick the hardest one? Question 10. You telling me. Did you notice? Oh, I only just have the answer. I don't have the thing, do I? So this was. Is this even the right one? 2 point. Tree diagrams. Question 9. Yeah, our tree diagram might not even be correct. Question 8. Question 9. Nope. Question 8. I don't get it. Tree diagrams is 2.5. We haven't, so it should be 2.4. Should be 2.4. So this is question 9, is it not? So 10D. Oh, it's question 10. C, 0.75. Hang on a sec. Why is this not?
I don't think it's the right question.
No, it's. Oh, what's it doing? It's 2.3, 2.4. Question 10. No. 2.3, 2.4. 2.4. Question 10. I'm looking at the other thing, that's why. I need question 10 from this. Is this the right one? Doesn't look like it is. A, B, C, D. This looks like it's totally different. 2.4. Not that. Is this question 10? No, that's the previous one. So why is it not question 10? It should be this. B and C are independent. Unfortunately, I don't have to. I'd have to find it. I don't even understand. Oh, no, we have to do this. Okay, back. Tree diagrams. You telling me you know these? I don't even know these. Let's see. If I contains this. Find the probability both. Yeah, both rows are the same color. Okay, this is gonna be fine, I believe. We have to draw these things. Now, 1 second. I have to find this thing. Stats 2. Not practice book. What am I doing wrong? 2.4 probability formulae. So it's not probability formulae. Tree diagrams is 2.5. So it is tree diagrams, which is 2.5, which is 2e. I tried 2e. This is question 10. Undoubtedly. There it is, question 10. What? There it is. Okay, our tree diagram's way wrong. That's why. Let's see. Oh, we just have to do an extra thing.
Yeah.
Yeah. Why would you make me do this? Why, bookie? Okay. So we had to do this. Yes, I deeply regret picking this question. I imagine this is an anomalous question. Okay. So we had to find the probability of D that the counter drawn from box B is blue. So
you just multiply all of them and add.
So you would have to do it, I think, for
all of them down blue.
At this level. That's
Yeah.
it. So we can't actually stop at that point. We have to see it all the way through. So we have to times each of those by the end as well. Okay. And
but I need blue, so why would you need to do the green ones?
So let me just check. So this initially is box A, isn't it?
Yeah, and then those are both box B.
Oh, these are both box B.
Yeah.
Both box B. A third counter is then drawn at random from the counters in box B. That's why we're going wrong. So let me just check. The event D occurs when the counter drawn from box B is blue. That's very, very badly worded, because the counter drawn from box B is blue could easily refer to this one. That's also box B. You must have to add those, surely.
No, but that's a second counter is drawn at random from box A and placed in box B.
They could have worded that better. Okay, so go on, try for this one, see if it works for these two.
But surely it would be like the other one that's blue, green, blue, that would also be included.
What, green, blue, blue?
No, blue, green, blue.
Blue, green, blue. Yes, I missed that.
And there's, that one as well.
Go on, try that, see if you get 27 over 49.
I got 199 over 98. That's not right.
Add.
Um, Okay, no, it's okay. I think I figured out why.
Okay, go on.
I accidentally put in plus signs instead of multiplying one of them. Now I got 27 over 49.
Okay, grand. So I just didn't understand the wording of the question. Grand. Okay, how about part D?
So you want both of them when it's the same color. So you just do 4, 7. Wait, I'm going to try it first. I got 11 over 49.
Okay. Hence find C union D.
Would it just be 1 minus 11 over 49? Oh, wait, it's PA plus PB minus P intersection. So since we know PC is 12 over 42, is that right?
Which one?
Wait, is it not 12 over 42? PC, probability of C.
The probability of C. The event C occurs when the two counters drawn from box A are also probability of C was 3 over 7.
Okay. So you do 3 over 7 plus 27 over 49 minus 11 over 49 to give you the union.
Okay.
Which gives you 37 over 49.
So 37 over 49. Where's this thing? So that's question 10. So question E, 37 over 49, and F.
Given that all three counters to and find the probability that they're all green. Okay.
How would you do that one?
So first you have to find the intersection between all three counters drawn are the same color and all green, which would just be the one that's all green. So that would be 4 over 7 times a half.
Yep.
And that got messed up. 1 half times 4 over 7, which is 8 over 49.
Okay.
And then you have to find the probability that all three counters drawn are the same color, which is 8 over 49 plus 3 over 7. Which is 13 over 49, and then you just do 8 over 49 divided by 13 over 49.
Okay.
Which is 8 over 13.
That's it. 8 over 13, and yeah, got it. Grand. So that was that one. Any questions there?
Kind of. How do you draw that tree diagram?
So I think the hardest part of this was just the wording, really. So if we just go here, so it comes from, let's see. So you've got green or blue. Whoops. You've got green. You've got blue. This is box A. So actually, the first part we were okay for, and then it's just this is box B, and then part that I missed, a third counter is then drawn at random from box B, and so it's just box B
Okay.
given box A and box B already. And these are green, blue, green, blue.
So you know the second box B, how would you find the probabilities for that?
This one,
Yeah.
it's as simple as, so if we just go back, so this was 3 over 6, 3 over 6. So that's 3 over 6. So what would be this one up here?
Um,
A third counter is then drawn.
2/6, 2/5.
2 over 6. Because it's box. This is box B. This is box B.
Yeah, so wouldn't it be? Oh, why would it be over 6? Sorry.
So it was initially. What was
When you
box A?
take one out, you.
So this was 4 over 7.
Yeah.
Box B had a total of 7 counters, did it? Oh, hang
No,
on. So box B had 7 counters. Sorry,
no,
5 counters. Yeah,
5.
it had 5 counters. And you added a counter from box A. So you told me 3 over 6 the first time. You told me these 4.
Yeah.
And so what is the probability then of taking... hang on, the third counter is then drawn at random from the counters in box B. So that's 3 over 6.
Why did they get 4/7?
Don't really get it. Those are matching up here.
Yeah, because it says a second counter is placed in box B after 3/6.
A counter is drawn at random from box A
So
and
it's
placed
like
box B.
one's
A
put in
second counter. Oh,
second out.
we were just totally. A second counter is drawn at random from box A and placed in box B. Ah, that's where they're getting it from. Okay.
Yeah, okay, I understand now.
Yeah. So now that's green. Yeah. It's just it's just an unnecessarily complicated question, I think. I picked it because it was the most complicated. Well, there you go. So tree diagrams.
Yeah, I know how to do tree diagrams unless it's like super complicated.
Yeah, me too. So any topic in particular? That was the end of conditional probability, anyway. Anything in particular you want to do next time?
Not really.
Okay. Well, you can let me know, or I can pick one. Any questions for me in general?
I guess we could do further differentiation. This is like trig and like E and lin because we just did it, but we spent like one lesson on it.
E to the x, trig, etc. Okay. Any questions for me in general?
No.
All right. Well done, Amogha. You did great, and I look forward to chatting again next week.
Thank you.
All right, have a good week. Goodbye.
Bye.